Welcome back. So this is the review for summative number 4, and there's quite a few sections on here that were on the last summative, so make sure you're getting better scores on those. The first section is a repeater section, so we're going to be using our graphing calculator to find zeros, max, min, and then increasing and decreasing intervals. I took off the end behavior question this time. We can assess that in different ways, but it does show up on the exponentials later, so don't worry, it's not going to be on the test for this particular question. First, we got to get it typed into our calculator. So you type in your function into Y1, and then hit zoom 6 to bring it to a standard window, or else maybe you reset your calculator before, and you should see this picture. So the first thing they want me to find are all of our x-intercepts, which are called zeros, and you find them one at a time by going to second trace and choosing the zero finder, number 2. So when it says left bound, they want you to scooch your cursor so that it's a little bit before the intercept, and I'm going to try to find this one first. So I'm going to scooch, scooch, scooch. Oops, it doesn't matter, I was far enough, but as long as you can tell that you're right before it, once you're there, hit enter, and then scooch, scooch, so you're a little bit after it, and then in between those two blue lines there should be the intercept, which is at negative 0.66, comma 0. So I would like you to round to the nearest hundredth. That'd be 2 decimal places. And you're going to do those same steps for your calculator. So second trace, pull up the zero finder again. So this time I'm trying to find this intercept. I got to get the cursor just before it. So I actually have to scooch with my right arrow. There we are, just before it. Hit enter. And then scooch a little bit after it. That's good enough. Hit enter. And then enter one last time. And I'm going to write down 1.330. And then the final one. Whoops, come back, calculator. Okay, same steps. Zero finder. Alright, I'm going to scooch, so I'm just before it. So, scooch. Oops, not before. There we go, enter. And then scooch, so you're just after it. Alright, so you should get 2.84. I realize I went through those steps a little fast. If you still need a refresher on how to use your calculator, and that didn't do it for you, there's lots of other videos you could access, which I already forgot the answer. What was it? 2.84. So what I should be doing now is I should be writing down all of these ordered pairs on my graph. You know this isn't going to go well for me, especially considering this is such a small graph. And there's really no chance that I'm going to be able to graph this accurately anyways. Alright, so now let's find the max and the min from our calculator. So this point right here is our maximum, and we're going to find it by choosing the maximum finder. So number 4 in the list. So I chose maximum, so when it says left bound I need to drag my cursor so it's just before the maximum. Scooch it over. That's good enough. Enter. And now right bound, go a little bit after the maximum. And then make sure you do write down the entire ordered pair, rounded to the, where are we at here? The 100th spot, so 0.15, and then 5.15. Now the other thing I would like you to encourage yourself to do is use a highlighter, which I don't know where my pens are, there we go, and highlight that x value from the turning point. That's going to be an important piece for our increasing and decreasing interval. I should also try to graph this. Good luck, Abruzzo. Good enough. Alright, so then I do the same steps. This time though we're finding a minimum. So second trace, minimum finder, number 3 this time. So here's your minimum. Scooch your cursor so it's a little bit before it. It's good enough. Enter. And then scooch so you're a little bit after it. Good enough. Enter. And then the minimum is located at 2.18, negative 3.19. And again, I would encourage you to use your highlighter or do something where you mark up the x value of your turning point. And let's see here. Just a moment. I'm gonna close this down. Should graph it. Good luck, Abruzzo. 2.18. Yeah, sure. Okay, so we all know the graph is, oh man, that's not even close. Okay, I think I'm about to give up on graphing. Just put a big frowny face there. That's not even close, right? Here's what I would like you all to do. Remember that number line trick we were using when we were practicing this again? I think that worked really well for you guys. So taking the x values from your turning points in the number line order, so least to greatest. And then the other thing you could mark on your number line is your infinity. So negative infinity lives on the left side and positive infinity on the right side. And I look at my roller coaster, it's increasing, and then it's decreasing, and then it's increasing. If you look at it strictly from like how's the roller coaster moving. So increasing, you can put a plus sign, or you can even write INC. And then the middle part is decreasing. You can even put DEC. And then it's increasing again. So when I ask you for when is your graph increasing, well, it's increasing right here and right here. So that would be negative infinity to 0.15 and 2.18 to infinity. It's decreasing from here to here. Notice my use of parentheses here instead of a bracket. I'm not going to count you wrong if you accidentally use a bracket, but technically we should be using parentheses. Alright, so that's how we're going to do graph analysis this time. I really encourage you guys to use the number line. I think it works beautifully. I want to see the number line on everybody's question. So just like always, we're going to be doing not every question, but every other question. This question is a bit of a thinker, right? So it says 2/3 to the negative x power. So what you need to think of this as is the -1 is separate from the x. So what's going on here? This 2/3 to the negative first power, it really means 2/3 to the negative first is really 3/2 to the x power. So that was a bit of a trick question, and that's because of this -1 power right here. So the base is really a 3/2, which is equal to 1.5, by the way. And that means you have an exponential growth, and you have to give me a big kid reason. You can't say because I graphed it and it goes up. You're going to say the base is 3/2, which is greater than 1. That's the reasoning. If the base was between 0 and 1, then you would have a decay. So there's a couple of trick questions on this review that you need to look really carefully at. This next one, again, it's a bit of a thinker. You don't really need your calculator. Here's the original, and I want you to graph me a new one that's been shifted to the right 2 and also up 9. So when I think about my function, it's b to the x minus h and then plus k. Where the horizontal shifting happens up in the exponent by the x, and it has a built-in negative, so we have to remember that. So your new function, which they want you to call g of x, still has a base of 7, still has an x, but this time it's shifted to the right 2, so it would be x minus 2 in the parentheses, and then up 9 would be a plus 9. So that's what I'm looking for on this question. You're going to create a new equation that has those two transformations. So tricky part there is remembering what horizontal piece goes where, horizontal up in the exponent, vertical outside of it, and that there's a built-in negative on the horizontal part. Alright, 4a. So again, you got a graphing calculator. I expect you to use it. You're going to get this typed into y1, and you're going to get some points off of your calculator. Now, the other thing, this is a great use of your highlighter again, this shift right here, which is the down shift, right? It's a vertical shift. It's going to match a whole bunch of other stuff, right? So first thing you're going to want to do is, use your table, grab some points off your table, which I probably didn't bother to do. These points aren't usually good, so don't go looking for good points. You're not going to find too many of them. But you're going to use your table. And here's what I'm going to notice. That highlighter I've been using, I could use it again right here on my graph. This will really help out. The downshift of -4 means that the asymptote line is now going to be at -4. When I graph this one, I'm going to fudge this in a little bit. 1 down 4. I can't graph very well, so I'm doing the best I can. But it looks something like this. This is an exponential growth. The base is a 5/4, which is 1.25, so that's why it's growth. It's greater than 1. The horizontal asymptote is the line y equals -4. So that -4 from the downshift is going to show up again right here. The domain on exponentials is very easy. It just goes forever from -infinity to +infinity. But your range is going to start at -4 and go up to infinity with one exception. -4 is an asymptote, which means it's not going to get there. So you're using a soft parenthesis on the -4. If you happen to use a bracket there, I will count you wrong. So here I am going to ask you for end behavior. We know that we always ask for left and right end behavior. And if you stay in that order, I think you'll all be happy. So this is left and this is right. So on the left side, your function is approaching a height of close to -4, excuse me. So I'm going to put a -4 there. And then on the right side, your function is approaching a height of up forever, which we call infinity. So again, that -4 shows up again. And if I was going to be a thorough test taker, you're going to see these -4s, these highlight marks, they're all matching up. And that's what I want to see when I'm graphing. Alright, so try those. Now we're on to the applications. At no point am I going to make you memorize the application formulas. They're going to be given to you. So on this question, these set of questions, I will have this formula written down. It'll say 1 plus or minus r to the t power. So whether you're growing or decaying is dependent on the question. You got to read the context clues. And then A stands for the initial amount, and then r is the rate written as a decimal. So the initial amount in this first question is a population of 816,000. And then in your parentheses, it does say increasing, so it's 1 plus increases by 2%. The 2% is the problem for most kids. It's 0.02. Remember, if you're trying to convert that to a decimal, you can either take 2 and divide it by 100, or some of you are just simply moving the decimal point over 2 times, but I find that some of you are not doing that right, so be careful. As increasing per year, they want to know the population after 12 years. So that is your t. So we're going to put 12 in the exponent here, and when you type this on your home screen, because you know time, so you're going to be in the home screen. This one, let's round it to the nearest whole person. So 1,034,885 people. So that seems like an easy question, I know, but I want you to practice 5B on your own, please. So then there's 6A and B, and this time they're looking for time. It says, when will it reach a certain price? So the fact that they don't give you time means that you're going to use your table. Alright, here we go. This antique car increasing 7.2% per year. And the current price is $5,600, and they want to know when it reaches 10,000. So the first thing I have to do is figure out what goes into my calculator. So the original price of $5,600, and then it's increasing. Careful on the decimal point movement here, guys. This is 7.2 divided by 100, which is 0.072. And then they don't tell me time. So I'm going to call that X on my calculator. And then we're going to go to our table, your XY table, and you're going to scroll down until you see it hit, what do they want, above 10,000? And an answer where it's like between so and so many years is fine. So like on this one, I think we're getting 8 to 9 years, between 8 and 9 years. Excuse me, I'm sorry. So knowing how to use your technology is the important part there. It's fine that I let you use your technology, but I'm actually assessing how well you use it. So no, I cannot answer any questions about how do I do this. So keep that in mind. All right, number 7A. They want to know the account balance after 5 years. They give you time, which means we're going to be on our home screen. They're going to give you a formula. Let's see. I think it looks like this. Principal 1 plus, because it's compounded, it's the r over n formula. And then to the nt power up top. Again, it's given to you. You don't have to do anything there. So they change out your variables a little bit. They call the principal the starting amount, which is 3,200. The R, of course, is your rate, which is 2.5%. Remember, we got to write that as 0.025 divided by 100. And then we have a new installment here of it's compounding, which means it's going to be compounding a certain amount per year. In this case, it's daily. So this is N, and daily means 365. And then, of course, T is 5. All right, so this is on our home screen. We are typing 3,200. And then we're going to open a parenthesis, 1 plus 0.025. And I'm going to be honest, guys, the most common mistake on this question, it's the decimal, the 0.025. Kids call it 0.25, which is 25%, which is not right. The other thing I see is kids are using N in the wrong spot. Remember, N is 365. It shows up right there, and it shows up right here as well. And then remember, you're multiplying it by T. So you're multiplying it by 5. If you're using an older calculator, this has to be in parentheses. We're on our home screen, and this is a money question, so you're going to round to the nearest cent. And I think you have 3626.06. All right, so 7B on your own, please. And this, the birthday money question. All right, so this is the question where it seems like they don't give you enough information. First of all, they do tell you it's compounding continuously, which means you're going to use this PERT formula, where E is a number on our calculator. The 3% interest is the R. So 3% is 0.03. And they don't tell you how much you invest. So you can start with any number. For me, I like to start with 100. Because that's a nice easy number to work with, right? So they want to know how long. So that means we don't have time, which means we're going to be using our table. It does say right in the instructions, use your calculator's table or your graph. I like to use the table. So in our calculator, we're going to need to program our y1 with our new function. For me, I'm using 100 for my principal. You're going to multiply it by the number e, and then up in the exponent, it's r, which is 0.03 times time. I don't know time. I'm going to leave it as x. So this gets typed on your calculator. And just to remind everybody where we find the e, I'm going to type this with you. So 100, right above the natural log key, you see e to the x. That's the best one to use because it brings up an exponent position. And you know you're going to have an exponent in this question, so you might as well just have it. And what do we want our money to do? I already forgot. I want it to triple, right? Triple? No. Double, excuse me, double. All right, so on my table, I'm going to be looking for my money to double, which means I'm going to be looking, whoops, get out of there, calculator. I'm going to be looking for $200. Because if I double 100, I have 200. All right, so to my table I go. And if you invested a different amount of money, you're going to get the same answer as us. I'm not worried about it. You're just looking for a different number, but it's going to be at the same time. Right about there, 23, 24 years. Closer to 23, but whatever. So an approximated answer here is all I'm looking for with the addition of the function itself. All right, this is an old topic, but it's back because we need to see it again. So, inverse functions. There's a very simple way to find the inverses. First of all, you got to remember that f of x is the same thing as y. So your first step is to switch the x and y around. So that becomes x equals 8y minus 5. And then your next step is to solve for y. So it would be easiest for me if I lock down the y and then I add the 5 over. So I have x plus 5 on the left side equals 8y. And then again, I'm trying to solve for y, so I'm going to divide everything by an 8. And I get, they already named it fancy for me. They named it f inverse. But x over 8 is fine. If you wanted to call that 1/8 x, that's fine too. Anything equivalent to the right answer, I will take. So that's not meant to be a difficult question. Please don't make it one. These might be a little tricky for you guys because last time I had you check all that were true, and this time I'm going to have you draw me examples and do some more higher level thinking, so be careful. Domain and range. When it comes to inverses, they switch. So if your domain of one guy is negative infinity to infinity, that means the range on the next guy will be negative infinity to infinity. Sometimes, always, or never, a function and its inverse are the same, and that is a sometimes. There's a couple of cases where they are the same function. Can you have a function whose inverse is not a function? And the answer there is yes. And that would be because of this next one. If the original passes the horizontal line test, then the inverse is a function. So be really careful on that question. You might have an original function, like for instance this guy right here. A parabola is a function, but he fails the horizontal line test. Sorry, yeah, horizontal. So that means the parabola's inverse is not a function. Sorry, that's very not legible. All right, try writing a little better, Abruzzo. These poor kids reading the slides. All right, and then the original and the inverse are reflections about the line y equals x. So I want to make it very clear, guys, that the questions that you're going to encounter on your test this time are going to be a little more like these next questions, so a little higher level thinking. Draw an example of an original function whose inverse is a function. All right, so for the original to be a function, I need the original to pass the vertical line test, and because you want it to be a function, you also need it to pass the horizontal line test for his inverse to be a function. So there's a lot of things you could draw for me, but like this is a good example of it passing the vertical line test, so it's a function, and it passes the horizontal line test because, and that makes his inverse a function. So draw an example of an original function. So I want the original to be a function, so it has to pass the vertical line test. But I want his inverse to not be a function. So this time I'm going to want to draw something that fails the horizontal line test. And we already had one of those earlier. I gave you an example of a parabola. I'll make it fancy and do an upside down parabola this time. This is a function. It passes the vertical line test, but it would fail the horizontal line test. So therefore his inverse is not a function. All right, and again, this is another example of something that was already tested, but we're going to try it again. And it says, how can you determine the maximum number of solutions in a polynomial and be able to explain? It matches the number of the degree. So whatever number is the degree, that is also the number of solutions. Now, more specifically, the maximum number of solutions. So some examples here would be like if you had a function f of x, 2x to the third minus 5x plus 1. This is a degree 3. So that means you're going to find 3 solutions. Another example, I'm going to mess it up, make it kind of weird, so be careful here. This function, now that remember the degree by definition is the highest exponent. This is a degree 5, so it could have as many as 5 solutions. So this time on the test, yeesh, I can't write. I want you to be able to explain how many solutions it has and why you know that. Alright, so this stuff, this is where you're going to go to your calculator, and you're going to get a little boost from your calculator. You're going to type this into Y1, and you're going to take a peek at the calculator, which I already have this. Not on my calculator, though. I already drew myself a sketch. I think it would be brilliant if you guys draw yourself a little sketch. It looks something like this when you graph it. Okay? And there is one clear place where it crosses the x-axis. It has an intercept at x equals -7, which you can go to your table and verify that, but it definitely crosses at -7. So that means on my calculator, I'm stealing that -7 and I'm going to throw it into my synthetic division. Now watch for coefficients missing. Sometimes they throw a sneak one in there, but there's a 1, a 7, a 9, and a 63. We're going to perform synthetic division. It's going to take this cubic and it's going to knock it down to a quadratic. Remember, if it's below the line, you multiply, and if it's above the line, you add. I like to put little lines in between them so I don't get my work all screwed up. And because of how this question works out, we should get a remainder of 0. So 1 times -7 is -7, and we add that up and get a 0. 0 times -7 is 0, and we add that up and we get a 9. And then 9 times -7 is -63. And I'm feeling good because I just got a remainder of 0. So this is your remainder. It should be 0 in the fundamental theorem questions. These are the coefficients to your answer. So remember, you started with an x to the third, and you knocked it down to an x squared. So this is 1x squared plus 9. I want you to find all of your solutions. So this quadratic is a little unique because when you solve it, you're going to use the square rooting method. And you get x squared equals -9. Now here, when you square root both sides, you got to remember a lot of things about your algebra life last semester. Your solutions are both positive and negative, and then -9 square rooted is a 3i. You get imaginary solutions. So here's what I'd like to see from you guys. The solutions. Remember how this was a degree 3 originally, a cubic? You should be listing out 3 solutions for me. You got positive 3i, you got negative 3i, and you also have -7, the one from the calculator. 1, 2, 3 solutions. All right. That, my friends, is the end of your test. Some old sections, some new sections. Either way, I want to see some good scores from you guys. All right. Thanks.